So today we are going to do question number 3 for my nature playlist, which is Koko eating bananas. It is the 875th question of report. Okay, so we have a monkey. Her name is Koko, and she loves eating bananas. And we have a pile of bananas. Let's say there are 4 piles, and we have 7, 3, 6, and let's say 11. So first pile has 7 bananas, second pile has 3, third pile has 6, and fourth pile has 11. Okay. Now there are some guards here, but the guards have gone away for some time. The guards are away, and they will come back here in h hours. H can be anything. Let's say h is equal to, let's say 7. No, let's say h equal to 4. Okay. So now Koko has to eat all these piles in this time. Now and the question allows us that we can decide a speed k, which will be k bananas per hour. So we can decide this number, and we have to choose any number we want to complete all the bananas in this amount. Okay, so let's say, what if I take 100? There is one rule though. Whatever I do, if I have 100 bananas per hour, that doesn't mean I can eat all of them at once. At max, Koko can eat one pile, like complete pile, in 1 hour. Okay, so let's say for this, if we have, even if we have speed 7 or 100, Koko will take 1 hour to eat this one. So let's say the speed is 7. Okay, let's say the k equal to 7 for now. K equal to 7. So 1 hour for this one. Again, we cannot do like 3 plus 4, 7. So 3 from here, 4 from here. The question specifically says that Koko can at max eat one full pile in 1 hour. So even though the speed is 7 per hour, Koko will still take 1 hour to eat this one, and 1 hour to eat this pile. And for this pile, first hour she will eat 7 bananas, but now 4 still left. For 4 she will take another hour. So 1 plus 1. So we got 1, 2, 3, 4, 5. But guards will come back in 4 hours. So the answer we have is greater than that one. So it is not a valid answer. So let's think of a better number. But if I just take 11, if I take 11, which is the max possible number, because even if I take, okay, for now let's see what happens with k equal to 11. For k equal to 11, as this is as 7 is less than equal to 11, so we have 1 hour. Same 3 is also less than equal to 11, so 1 hour. 6 also less than equal to 11, so 1 hour. And 11 also less than equal to 11, so we got 1 hour here. 1, 2, 3, 4, we got 4 hours, and 4 hours is the answer. Okay, so k equal to 11 is a valid answer. But if k equal to 12, again 1 hour, 2 hour, 3 hour, 4 hour. But if k equal to 50, 1 hour, 2 hour, 3 hour, 4 hour, anything greater than 11 is a valid answer. But the question says take the minimum one. We don't want to take a higher number because that is not optimal. Like, why should I take a speed as 500 per hour when 11 is enough? Okay, so the question asks, out of all the valid speeds in which Koko can eat all the piles in under h hours, either h hours or less than h hours. So we have to take a minimum possible number. Okay, let's take another example, so we can see the pattern behind the question. Let's say the array is 30, 11, 23, and 4, and 20. Okay, and h equal to 5. Now we can see again the number of hours and the size of array is equal. So as you have seen by now the pattern, if we take the max element is 30, okay, 11, 23, 4, 20, 30. So if we take any number that is less than 30, even if we take 29, 29 is greater than all these numbers. So 1, 1, 1, 1, like 1 hour for this, 1 hour, 1 hour, 1 hour. But for this one, 29 plus 1, because in the first hour Koko can eat only 29 bananas. In the second hour she will eat 1 banana. So it will take 2 hours to eat this one. So 2 hours for this, 1, 1, 1, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6 hours. But we want to do it in 5. So this number is not even valid. We were asked, out of all valid numbers, keep the smallest one. But this is the invalid category. So for this we want at least 30 and anything greater than 30, but that 30 is the smallest, so we get this is the answer. Okay. Now let's say if the question was like the hours were different. If the hours were, let's say 7. Okay. So that means we can spare 3 more hours, like 1, 2, 3, 4, 5, and we can spare 2 more hours after this. So we can try to like reduce the answer. Okay, so let's say, but if we take 20, okay. So for 20, we get 2 hours for this one. 1 because 11 is less than equal to 20. Okay. 23, again it is greater than 20, so we have 2 hours. For 4, we have 1 hour. For 20, we have 1 hour. 1, 2, 3, 4, 5, 6, 7. See, for 20, we get 7 hours, so it is a valid answer. So 20 is valid, but about 19? Let's check 19. For 19, we have 2 hours, 1, 2, and 1, and 2 again, because 19 plus 1. Okay, So 2, 3, 4, 5, 6, 7, 8. 8 is not less than 7, so not valid. Okay. So what we did was we have to check a lot of numbers. Like for this we see the array, but let's say arrays are very big. So what we will do is we will try, let's say 50, then we will try 49. Like even if 50 is valid, we have to check 4 numbers. Okay. So let's say 49 is also valid, we check 48 also valid. Let's say we keep checking until 30 is valid and 29 is not valid. So see, we check 20 times, and each time we do the check function. Check function is what does is, let's say we assume k equal to 40. We assume it. Now we have to check if it is valid or not. So we have to do a full loop, and we have to count the number of hours. Like we have to do 40, 30 divided by 40, seal, and 11 divided by 40, and so on. So like each time we run a check function, we have to do O of n. And this O of n we do a lot of times because we do many checks. We don't have the variable, so let's call it x. Okay. So how to optimize this? Okay, first of all, let's see what is the check function. Check function is a simple for loop for like starting to end. Let's say if the array is 3, 7, 6, 11, and let's say h is equal to 6, and let's say we have k. For now, the k is in this function we have check k, because we send a variable speed and we check if it is valid or not. So let's say k is equal to 4. Okay. So what we do is, for each value, like in the loop, we do array of I divided by k. So 3 by 4 equal to 0, but not 0, it should take 1 hour. Okay. So we take the seal value of this. Because why seal? Because let's say 7. If we do 7 by 4, we get 1. Because in any language, if we divide a number by number, so if the answer is, let's say 1.7 something, like Java for example will return 1. So we want 2 instead. So we want give the mat.seal value of this. So for 7 divided by 4 seal, we got 2, because 2 hours for this one. Okay, 1, 2, and similarly we keep adding on time. This is the time for each value, and we keep adding it. So array of I divided by k plus array of I divided by k, each time seal, plus array of I divided by k plus array of I divided by k, and then we get the final time value, and then we compare it with the h. Let's say for this we get 1, 2, 3, is for 2 again 2, and for this 3. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So we get 8, and it is greater than 6. So this function will return a false, because the time we got is greater than the time we are allowed. Okay, so each check function will give us O of n complexity, in which n is the length of the array. So we did the check function. Now how to optimize the number of checks we do to check all the possible values and get the smallest one? Again, we will do just binary search, so that we don't have to check every number. We just keep on jumping. Okay, so now let's see up for a pattern. For 30, 11, 23, 4, 20. For this array, what is the minimum number we can choose? You might say 4, but even if we take 4, we get 1 hour for this, 5 hours, 6 hours, 3 hours, and 8 hours. Okay, so we got 8 plus 3, 11, plus 6, 17, plus 1, 18, plus 5, we get 23 hours. Okay, but what if the we took 4? Okay, and what if the answer is, let's say like the hours are 30? So the number of hours we get from having a speed of 4 per second, 4 bananas per second, we get 23 hours, but we are allowed to do it in 30. Why are we doing it so fast? The question specifically says that keep the k as the lowest value. So there are 3 values less than 4. Why don't we check them and then see what is the minimum value we can take, so that we get close to this one? Because we are allowed 30 hours, we are doing it 23, we have 7 hours to spare. So why are we sparing? The question specifically says don't take a higher number just because you can, take as small as possible. So we have to check 1, 3, 2, and 1 also. But we cannot do 0, because 0 banana per second means infinite hours. So the minimum value is 1 and not 4. Okay, so we don't take the minimum of the array. Minimum of array we don't take, we take the 1 as the minimum element. Okay, so we have the min. For binary search we need 2 numbers, min and the max. So we know for sure at minimum we have to take 1 hour. But what about max? Now okay, let's see. For max, what if I take infinity? I mean mat dot int dot max. Again, even if I take, as I said earlier, 30 is the max element of this array. Okay, even if I take 50, even if I take 31 will give us same answer as 30, because like for 30 we have 1, 1, 1, 1, 1. Okay, because it is a max number, so every number is smaller than it, and it itself is equal to itself. So as long as we have any number which is less than equal to k, will give 1 hour. So only one number is k, and all numbers are less than k. So we have 5 hours. Even if I do 31, I still get 1, 2, 3, 4, 5, because all numbers are less than 31. If I do 41, all numbers are less than 41. So again 5 hours. So if we take the max element of the array as the k, then the hours we get equal to the length of array. Now even if I take max plus 1, max plus 10, max plus 100, I still get n hours. Okay, so there is no point in taking greater than number of this. So we got our numbers, minimum equal to 1 and max equal to the max of array. So now all we have to do is just do the binary search, and then we will get the answer in very less time complexity. So the min is 1 and the max is, for this case, 30. Okay, so low plus high upon 2, we get mid. This is the mid number. So let's check this one. If this is not valid, that means anything smaller than this is also not valid, because if 15 hours, if 15 per second is not enough, then 5 per second will also be not enough, because 15 is greater than 5, and even 15 is not enough to do it in h hours. Okay, so let's see if we do 15. Let's say the hours are 7. For 15 we have 2, 1, 2, 1, 2. So 2, 3, 5, 6, 8. But we have to do it in 7 hours. That means 15 is not valid. So anything less than 15 is also not valid. Okay, as I discussed earlier. So now we have low equal to 16 and high equal to 30. Again we take the mid of this. If 46 upon 2, we will get 23. Okay, now check 23. For 23 we have, let me erase some values from here so that we have some space. 11, 23, 4. Okay, so now we have a greater number which is 23. Now let's check if can 23 do it in 7 hours or not. So 2, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6. We got 6 hours, but we want to do 7 hours. So we are safe. That means 23 or anything greater than 23 is valid. Okay, so don't check it. We know 23 is the max number so far. That for now, sorry, 23 is the minimum number so far, which is the answer. So let's save 23 as the answer. And now let's do high equal to mid minus 1. So we have 22. Let me erase this a bit. So now 16 to 21 is the range in which we have to check. Okay, 16 to 22. Because see, we know 23 is the answer. So we saved it. But what if there is a smaller answer there? Because we did it in 6 hours, we have 7. We have 1 extra. So let's try taking up a smaller value and then see what it is valid or not. Okay. So now high is here, low is here. 16 plus 22 is 38, and the mid will be 19. Check for 19 now. So 2, 1, 2, 1, and 2. 2, 3, 4, 5, 6, 7, 8. We get 8 hours, but the allotment is 7. That means 19 is not an answer. So if 19 is not, then 17, 18 are also not answer. 16 is also not answer. So now answer is somewhere between 20, 21, and 22. Okay, so low is here. Now mid will be 21. 21 we check. It will be 2, 1, 2, 1, 1. 1, 2, 3, 4, 5, 6, 7. 7 is safe. 21 is the answer. So 23 was the answer before. We remove it. We switch to 21 is the answer we know. Now let's check what if there is a smaller value. So we reduce this part of the array, and now high is here. High and low are at the same point now. 20. Let's check 20. For this we have 2. Let me erase this again so we have some space. For 20 we have 2, 1, 2, 1, and 1. So 1, 2, 3, 4, 5, 6, 7. 7 is safe. That means 20 is also the safe answer. So we save 20. Right now we see that this is last value, but binary search doesn't know that. So what we will do is, it will say 20 is the answer. Let's check even smaller. Okay. So we reduce this, and now L is here. Now binary search knows that L has crossed. No, actually it is H. And L. So H is now here. So now binary search knows that L is going here, H is going here, and now H has crossed L. So now H is here and L is here. So at this condition, binary search stops, because we were checking like this, and then when they cross, we stop there. Okay. So this was all the solution, and we were able to do it in. See, earlier in the brute force solution, we were doing O of, let's say, 1 to max. Max, let's say M. M is the max element of the array. So O of M times we check, like max, and so on until 1. M times we check, and each check takes n time. Okay, because we do the one loop for the full array. So O of M into n was the previous answer, but for now, see, the check will always take the same time, but we just reduce the number of checks. So now we didn't check every number possible. We just checked, like we checked 1, and then we reduce the search space by half, and we keep on doing that. So it will log our base to M. Oh, so we got n log M. So this time is way better than the previous one, and the space is often. So that is the power of binary search, and all questions are can be done like that, and it is called BS on answers, binary search on answers, because we know the answers, and now we do the binary search on the answers to get the minimum answer possible. Like the kind of question which has min, max, or max, min, maximum number possible to do this in min hours, like this. So these are called by BS on answers. Okay. Thanks for watching. I will see you in the next video.